Warm greetings. Welcome to this tutorial on general features in Avogadro. In this tutorial, we will learn about proton transfer in compounds by changing pH values, load crystal structures, show various Miller planes, build supercells, show geometries in coordination compounds, and build nanotubes. Here I am using Ubuntu Linux OS version 14.04, Avogadro version 1.1.1. To follow this tutorial, you should be familiar with Avogadro interface. If not, for relevant tutorials, please visit our website. Example files used in this tutorial are provided as code files. I have opened a new Avogadro window. I will demonstrate proton transfer in compounds by changing pH values. For this, I will load amino acids from fragment library. Using Build menu, go to Fragment Library. In the Fragment Library, double-click on Amino Acids folder. Select d-alanine.cml and click on Insert. Close Insert Fragment dialog box. Press Ctrl Shift and A to deselect the structure. Using Navigation tool, rotate the structure for proper orientation. I will demonstrate proton transfer in amino acids by changing pH. Go to Build menu and select Add hydrogens for pH. Add hydrogens for pH text box opens with default value 7.4. In the text box, change pH value to 7.0. Click OK. Notice the structure. Carboxylic group has been converted to carboxylate ion. Amino group gets protonated. Go to Build menu and select Add hydrogens for pH. In the text box, change pH to 2.0 and click OK. Carboxylate ion has been converted to carboxylic group. Go to Build menu and select Add hydrogens for pH. In the text box, change pH to 10.0 and click OK. Carboxylic group has been converted to carboxylate ion. Amino group is deprotonated. Press Delete key to delete the structure. Now I will demonstrate proton transfer in amines by changing pH. For this, I will load ethyl amine structure from Fragment Library. Close Insert Fragment dialog box. Press Ctrl Shift and A to deselect the structure. Using Navigation tool, rotate the structure for proper orientation. Go to Build menu, click on Add hydrogens for pH. Add hydrogens for pH text box opens. In the text box, change pH value to 7.0. Click on OK. Observe the structure. Amino group is protonated. Go to Build menu, click on Add hydrogens for pH. In the text box, change pH to 2.0 and click OK. Here we see no change in the structure, as ethyl amine shows proton transfer in basic medium only. Go to Build menu, click on Add hydrogens for pH. In the text box, change pH to 10.0 and click OK. Amino group gets deprotonated. Now I will demonstrate how to load crystal structures from Crystal Library and some crystal properties. Click on New icon on the toolbar to open a new window. Go to File menu, navigate to Import and select Crystal. Insert Crystal dialog box opens. Here we can see different folders. Double-click on Halides folder. Select NaCl halide.cif file and click on Insert. Close Insert Crystal dialog box. Here I will close Tool Settings and Display Settings for proper view. Crystal structure of sodium chloride is displayed on the panel. Along with the structure, its cell parameters are displayed. On the top left side of the panel, you can see lattice type, space group, and unit cell volume of sodium chloride crystal. Now I will show Miller planes for this crystal. Before that, I will give a brief introduction about Miller indices. Miller indices are a set of three numbers H, K, L. They are used to specify directions and internal planes in crystal systems. Now to Miller planes in sodium chloride crystal. Go to View menu and click on Crystal View Options. Crystal View Options menu gets loaded on the right. Click on Miller Indices radio button. I will change the values of H, K, L to 2, 3, 2. Notice the change in planes and position of atoms in the crystal. Now I will explain how to build a supercell. Go to Build menu and select Supercell Builder. Supercell Parameters dialog box opens. Under Supercell options, we can change unit cell parameters A, B and C. I will change the field values of A, B and C to 2, 2, 2. Then click on Generate Cell. Click on Close to close the dialog box. Zoom the structure as required for proper view. Crystal lattice is displayed on the panel. Now I will change Miller indices to 3, 2, 3. Rotate the cell using navigation tool. Here dotted figure shows the plane. You can see various planes by changing H, K, L values. Now I will build octahedral geometry for hexamine cobalt 3. Click on New icon on the toolbar to open a new window. To draw hexamine cobalt 3, click on Draw Tool icon. In the element drop-down, select Other. Periodic table window opens. Select cobalt from the table. Close periodic table window. Click on the panel. Select nitrogen from element drop-down. Click and drag to draw 6 bonds on cobalt atom. Notice that each nitrogen has 2 attached hydrogens. In hexamine cobalt 3 structure, each nitrogen has 3 attached hydrogens. Select hydrogen from element drop-down. Click and drag on all nitrogen atoms. Hexamine cobalt 3 structure is drawn on the panel. Click on Display Settings button to open Display Settings menu. Now I will show octahedral geometry of hexamine cobalt 3 structure. For this, I will use Polygon Display Type. If Polygon Display Type is not activated, use Add button to activate. Click on Polygon Display Type checkbox. To optimize, click on Auto Optimization tool on the toolbar. In the Force Field drop-down, select UFF. Click on Start button to optimize. Click on Stop to stop the auto optimization process. Using navigation tool, rotate the structure to see octahedral geometry. Similarly, this is pentagonal bipyramidal geometry of iodine heptafluoride. Now we will see another feature in Build menu called Nanotube Builder. A nanotube is a nanometer scale tube-like structure. Examples of different types of nanotubes are boron carbon nitrogen, boron carbon and carbon. A carbon nanotube is a miniature cylindrical carbon structure. that has hexagonal graphite molecules attached at the edges. Click on New icon on the toolbar to open a new window. For a better view of the nanotube, I will change background color to blue. Go to View and navigate to Set Background Color. Select Color dialog box opens. In the box, select blue color and click OK. Go to Build menu and select Nanotube Builder. Nanotube Builder menu opens below the panel. I will resize Avogadro window to view Nanotube Builder menu. You can set chirality indexes n, m to determine the type of nanotube. I will set index values n and m to 4 and 4. Change length to 4.00. Set unit field to periodic units. Click on Find Double Bonds checkbox to show double bonds in the nanotube. Then click on Build. Press Ctrl+Shift+A to deselect the structure. Using navigation tool, rotate and zoom the nanotube for proper view. Next, I will build a nanotube with 6 index values. Go to Build menu and select Nanotube Builder. Change n and m values to 6 and 6. Then click on Build. Notice the two overlapping nanotubes. To optimize the nanotubes, click on Auto Optimization tool. In the Force Field drop-down, select MMFF94. Click on Start button to optimize. Click on Stop to stop the auto optimization process. Press Ctrl+Shift+A to deselect the structure. A double-walled nanotube is displayed on the panel. Using navigation tool, rotate the nanotube for proper view. Now I will show carbon hexagon rings in the nanotube. In the Display Types menu, select Ring checkbox. Using navigation tool, rotate the nanotube to see carbon hexagons. Let us summarize. In this tutorial, we have learnt about proton transfer in compounds by changing pH values, load crystal structures from crystal library, show various Miller planes, build supercells, show geometries in coordination compounds, and build nanotubes. As an assignment, load silver chloride crystal structure and show its Miller planes. Load structures from coordination library and show geometries. Build a nanotube with chirality index 9, 9. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials and give certificates. Please contact us. The Spoken Tutorial project is funded by NMEICT MHRD Government of India. This is Madhuri Ganpati signing off. Thank you for joining.